If
Yes,
you can,
please.
can you see
Yeah,
my screen?
we can
Yeah.
see it here.
So, good afternoon or good morning, whatever and wherever you are joining with us this for this session of AI and robotics live streaming. Myself is Dr. Somaya Banerjee. I am representing as Senior Vice President Innovation Research, lead of Trasna Solutions Europe. So we are trying to present the kind of the hardware integrity and the novel solutions which Trasna is providing as a roadmap to design a scalable, integrated, and adaptive AI-enabled accelerators with some customized use cases, focusing mainly on the RISC V processors. So before going to the next topic of the entire content, I would like to introduce Trasna a bit. Trasna is focused on technology leadership, and in a nutshell, that it always try to focus the blockchain and AI integration to deliver most of the innovative and optimized solution on the system on chip. And the most focusing features of the Trasna solutions are not only the system on chip, but also it encompasses a lot of other application vertical as well, like ICM and GNSS technology. And based on this trend, we'll try to introduce that how we are Trasna is trying to innovate and trying to think a roadmap how the device of the next generation or future AI devices will look like, and will give a behavioral aspects of the application and the practical technology. So if you can see my screen, then it shows that's a kind of technology trend. The flashback is 1970, where Intel came into the market with 4004 microprocessors. I'll be using some buzzwords, but I will try to describe those buzzwords in a brief so that everyone can understand. So everyone knows that buzzword Intel Inside, and it was the Moore who actually founder and the establishment of this buzzword of Intel. And according to his principle, it was 2004, 2015, 2016, and 2017. Every year there is a kind of increasing and by leaps and bounds jump for the transistor market, for the semiconductor market as well. But after 2017, it is calculated that in 2023 that the Moore laws will be obsolete by 2036. So what is the reason behind it? Reason to get the reason, we have to investigate a little bit past, where the Heisenberg in 1927, he's a German physicist, he was a Nobel laureate, and he told that you cannot predict the location and speed of a particle, I mean to say the photon, electrons, and other particles which actually drives the semiconductor paradigm. And at the same time, if you are not able to locate the speed and the particle at the same time, then it will be very uncertain to design a particular chip or wafer or any kind of semiconductor technology. And also you need to restrict yourself in terms of the transistors space and the small power capacity and the density of the components and the chip on the system. So these kind of principle, which was way back in 1927 from Winsberg, and this has become true, that we cannot make more chip produced in terms of power density and in terms of space. So what is the impact of AI here? Due to the fact that everyone knows that AI is a kind of data centric and data driven technologies. So most of the AI techniques are having a lot of computational powers, a lot of computational energy, and excellent type of training and supervised sessions out of the box. I mean, off the chip and on the cloud. But as we are talking on the chip, on the hardware devices, so we don't have much flexibility and luxury here to show that kind of computational and energy efficiency trend. So that's why Trasna and for all other market trends, we are trying to build up some accelerators. So accelerator is a kind of class of hardware and software, of course. Although I am showing the more of the things on the hardware and software mix, but it is a co-design, you can say. So it will just produce a certain number of enhancement and acceleration for the AI applications. But to more to say that most of the AI applications are, I told that it's very computationally expensive, and it takes a lot of training and data hungry operations. So that's why not all the hardware accelerator which Trasna will be building up in terms of their practical applications that will support all AI applications. So it will restrict some of the use cases, which I will try to mention later on. So this is the design of the accelerator and the background of the accelerator. So what is the problem here is that till now there was some kind of core systems. You can remember that Intel Inside, that was cores kind of microprocessors. So now in the market there is called multi-core systems. That means you have the serial and you have the parallel in combination. It simplifies that it can be GPU, that is graphical processing unit, it can be CPU, which is serial, again the FPGA, and there is some custom hardwares. So why this is? Because the AI task and AI related algorithms, they require more power and more energy and more computational resource to deliver. So you can see the instances that Samsung is 2016 and Samsung 2019, they have produced different kind of AI chipsets, and they have different kind of AI compatibility, because you can imagine that from 2016 to 2019 there was a major shift of the AI applications. So most of the AI applications are going for the handset and the mobile devices. So that's why they are trying to put their instances in a different way. So now in the market, you can see there are excellent areas of heterogeneous SoC or multi-core system on chip. Why I am showing this? Because there are big players where you can achieve these kind of multi-core systems you can purchase. But at the same time, those multi-core systems which are available in the market, that are not fully compatible. So that's why Trasna will be coming to the edge. But what the challenges we found here, that is the few challenges I mentioned here, that is the latency, quality of service, security, privacy, bandwidth, and cost. Out of this, that whenever we call about edge AI or edge ML, we have the particular problem of the latency and security. That is the most corresponding problems which has a different kind of challenges to develop any kind of accelerator systems in terms of hardware and software. So what Trasna will deliver, Trasna will try to find the MLH is different, because we are trying to find out some models, trying to deliver some development in terms of tiny neural networks, that is a small neural networks. We are trying to restrict the computational training sessions in a smaller batch size, so that we cannot spend more computational resources. We have to make our devices cost prone. Areas and size are limited. We know that semiconductor devices are not very much flexible for their spaces. And as Trasna is focused on the smart designing application, so we are trying to make the design more smarter. But the most important thing is that most of the edge devices, they are not focused or they are not specific for only AI applications. So we need to be very flexible, that whenever there will be non-AI applications, this device or this kind of chip or this kind of hardware should support the application as well. So considering all these trends in the merit or in the mind, we are trying to making some kind of innovations and some kind of modification of the market strategies, where we can find out the accelerated functional unit, which is called AFU, and another components we are trying to introduce here, that is called accelerated processing unit, that is APU. In brief, what is happening here nowadays, we are using 3D memory. 3D memory means that you can directly jump with the SRAM, DRAM, and non-volatile memory in terms of not making any kind of data movements with the accumulator or with the main processing system. So it's basically called as 3D memory, and for this 3D memory, you are having a kind of capability that is called PIM. So PIM is a kind of special features which the AI application actually supports, that is called processing in memory. So processing in memory reduces your data movements. So whenever you are going to reduce the data movement, in turn you are going to reduce the energy, you are going to reduce the computational resources and bandwidth at the same time. So these kind of AFU and APU combinations will give you more flexibility whenever you are trying to design for AI applications on the. What are the innovations we are trying to produce? We are trying to mainly focus to innovate the instruction set architecture, which is called ISA. And most of the computational problems of machine learning are requiring complex matrix multiplications and complex mathematical operations. To support those kind of operations with limited amount of energy and limited amount of space, we are trying to produce some ISA or instruction set architecture, which can operate on multiple data packed into vector in parallel. So that means you are having a vector matrix multiplication but with a low energy cost and with a low space and low computational cost. So in terms of achieving those kind of things, we are having two optimization strategies from Trasna. One is that called that on-chip network. That is the that how we can reduce the movement of the data, as I mentioned earlier, that you have the three-dimensional memory, and at the same time you have a limited local memory, that is LLM. That is, you can distribute your memory configuration where each core will directly access only its small local memory. So at each and every instances and each and every iterations, you don't have to interact with the main memory. So in this case, you are trying to reduce your movements, and of course you can reduce the cost and the energy savings operation at the same time. So as I also mentioned, the processing in memory, PIM, to reduce the data traffic between the memory and the processor. So this is the most significant things which we are trying to produce. And if we are trying to produce this, there are some kind of market trends. Market trends is that the all AI applications, like the normal use cases, which I will try to show, they are using multiple convolutional neural networks. That means there are many neural networks which they can combine to accelerate the AI operations. But what happens? What happens is that there is a larger leakage current, there is a longer delay time, and there is a lower reliability and higher cost. So to manage these kind of things, from Trasna, we are trying to develop a kind of new algorithm that is called deep reinforce, which will try to optimally select the particular convolution neural network, which will only take the low delay time, the minimum leakage current distributions, and at the same time higher reliability and less latency. So for this, we are trying to divide our sectors in two sections. One is the hardware sections, another is the software sections. In the software sections, we will trying to introduce the open source TVM model, which is called Tensor Virtual Machine, which is an open source deep learning. And this deep learning will support, the existing stuff of TensorFlow, PyTorch, and Keras. And to introduce more on this, Trasna is also developing a hardware neural network, and I'm trying to show you some basic circuits where we are using some kind of summation amplifiers. We are trying to use some kind of activations, and we are trying to use some weighting. So let me tell you this activation function. Activation function is the key of AI applications, and you can see the most existing applications, activation functions in the market, like ReLU, like sigmoid, like tan hyperbolic, etc. So, but these activation functions are taking lots and lots of energy computations. So in terms of reducing those energy computations, from Trasna, we are trying to make a HNN, that is called hardware neural network. And this hardware neural network will give a very small space of some kind of summation amplifiers or operational amplifiers. And then we have trying to make some more activations like tan hyperbolic and the sigmoid here. And to calculate the computational calculations or weight or matrix multiplications, we are using some kind of weighting circuits here. So you can see if these circuit simulations are okay and perfect, then we can also optimize their placement on our design. And that's why you are having a limited latency to the propagation delay to each neural layers. So compiling these facts, we are trying to make use of some life cycles, or you can say designing ecosystems, where you can find out that register transfer level, that's RTL, that should be controlled as a backend from the Trasna, and all other components like TVM, which I mentioned, that is a C code generation, which is a open source deep learning library, which will support the existing library for the development. So I'm trying to show you some kind of code snippets here, that how we will be using the open source deep learning library without custom instruction and with custom instruction, because I told that there will be an instruction set extension for this kind of accelerators, and all the use cases cannot be supported with these kind of accelerators. So what are those use cases? So normally we will be following these kind of steps. We will try to input some neural networks like PyTorch, Keras, and TensorFlow. Everyone is knowing this. These are very common. And we are having this TVM, Tensor Virtual Machine, which is a open source deep learning library, which will generate a C source code for us, which we can modify that code. And then Trasna will make an adaptive backend, which I already showed that the reinforcement-based AI-based applications which will actually control the SDK and the register transfer levels. So with these kind of technology, we can also expect that it will support multiple type of libraries, and it will also support the quantizations. And moreover, we are trying to make it 64-bit and 128-bit compatibility to support all the levels of RISC. So if you can see the industry innovations, I have taken this slide from the RISC 5 summit, and they are telling that from 2021 it will be more on the AI and SoC, that is system on chip applications. Reason being that clouds are not much secured right now, and at the same time the cost of the cloud, the big four like Amazon or Oracle or other cloud operators, even the Alibaba, they are also having a huge cost margin to give you the leverage for the cloud services. So showing this kind of cloud services, we are trying to build up this application on the hardware side so that we can make the accelerator, and the accelerator will support us in terms of software and hardware use cases. But as I told you, that use cases should be very restricted in the initial level. So for Trasna, we are trying to make some kind of face recognition system, some kind of object detections. We call it smart mirror. And we also trying to pull out some gesture detection and speech recognitions, but all are at the very limited kind of use cases and restricted use cases. You can say these are all smart living scenarios. And also we are trying to make some kind of predictive and remote maintenance to support these kind of use cases from the chip. So these are the couple of innovations and a couple of roadmaps which we are trying to achieve here from Trasna, and we are quite confident that we'll be coming out with kind of new accelerator in the market which are better than existing one, which will support the low power and many constraint around devices. And everyone knows that the devices are not very much random to use, and those devices are a lot having constraints, and also the cost and the space and the energy efficiency is one of the big factor to sustain the market. Thank you so much. If you're having any kind of applications, questions, articles, you can catch us at Trasna.io.
Yeah, thank you, Sumia, for this presentation about Trasna's plan to address AI and IoT in this. I have a couple of questions, Sumia.
Yeah, sure.
First, what is the main impact of AI on IoT, or what are the main impacts of AI on IoT from your perspective?
This question has several answers, but the primary two answers are very common. That whenever we are trying to combine AI and IoT, we are having two things in mind. One is these IoT devices should be secured, and at the same time it should be adaptive with the context and the environment, because all the IoT applications are very smart and they cannot be adopted with all the applications. As I mentioned, that there should be specific use cases, and for the specific use cases you require specific IoT devices.
Okay.
So our devices should be adaptive and smart to support the environment, and at the same time it should be private and it should be very much secure and trusted.
Thank you. This is clear. Then the next question is this new move, this AI. Why this new AI move will require new computing resources for edge devices? What are the use cases that show real benefits? I think you went through it in your presentation, but if you can, give.
I can summarize.
Please.
I can summarize that the accelerator is required because all we are talking about the AI cloud. Because whenever you are playing with the cloud, you have the luxury to offload your data and to offload your task with the third party. But what happens whenever you are having a mobile phone or having an edge device and you are trying to make it more intelligent? That means you cannot depend on the third party services more. Rather, you have to depend on the device side on the more. So if you have to augment, you have to modify your device, then you have to make some kind of accelerator, some kind of booster to create your AI application faster. Because all the AI application, as I mentioned, it is very computationally expensive and they are resource hungry systems. So it consumes a lot of resources and consumes a lot of energy. So if your devices, maybe a mobile devices, it gets a kind of hit or kind of very much computational resource manipulative devices, then you will not be liking it. So your ambition and your objective is to make more your device intelligent, so that it can be just like under your control without depending on the third party. So we need some kind of modification of the existing AI technology from cloud to device.
Clear. Thank you